Okay, so we're finding our slope. We've already done this. Subtract y, negative 15. And then on the bottom we have x subtract x. So this becomes plus 15. This becomes 10 plus 15, which is 25. And so we end up with 3/5. Okay. So now we need to do point slope form, which is going to look like this. And you have this in your notes. And it's on the poster, right? And does it matter which of these 2 points we use? No. So I'm going to use this one first. So y subtract, what is y sub 1?
0.
Yeah. Equals the slope times x subtract 10. So of course this is just y, right? Y equals 3/5 times x, and then 3/5 times negative 10, which is negative. So did you guys do 3/5 times 10? I would think I would reduce. I would say 5 goes into 10 twice, and then 2 times 3 is just 6, isn't it? Okay. Now, if you use the other point, it'll still work. And this is the way cool part about math. Y subtract y sub 1, which is negative 15, equals the slope times x subtract x sub 1, which is also negative 15 in this case. So this is plus 15, and that's plus 15. Y plus 15 equals 3/5 x, 3/5 times x, plus 3/5 times 15. Isn't that 9? I heard a yes, and I didn't hear any other yeses or see any other heads. No.
It's 9.
Okay, 9. And then can I get rid of this 15 right here?
Yep.
Subtract 15 from both sides. 9 subtract 15. Same equation. There we go. Same equation.
Yeah, looks good.
Okay. So we're just going to do some problems, and I'm just going to ask you guys to help me, and there you go. So here's a point. Here's a slope. All right. So can we write this equation? Okay. Angel, want to help me start? Let's do point slope form. How's it start? I heard y. Minus 3. Almost. Y sub 1. Yep. Very good. Okay. So y subtract negative 1. Okay, Matt. Equals what?
Negative 2.
Okay, good. And then in the parentheses, Shannon, what am I going to have in the parentheses? X subtract 3. What do you guys think? Can we just get those 3 variables where they go? Okay. And then this double negative business, that's something we've got to do right. We've got to write down y subtract, and then when y or x is a negative, get that down too. Okay? So this is the equation of the line that goes through this point and has this slope. It's not in the form we want, Matt. That's point. It's not in the form that we want, okay? But it is at least an equation. And now we can make the form better, I think. Don't you? Okay. So Georgia, what do you want to do first? What do you see here that's kind of bugging you? Parentheses. Should we do that first? I think that would be fine. This is negative 2 times x, and negative 2 times negative 3, plus 6, right? Okay. Gracie Huntington, on the left-hand side, do you see anything that's bugging you? Well, before I worry about getting rid of this, do you want to? Can we take care of this double negative?
Yeah.
Everybody, don't you think that's a good idea to take care of that double negative business before we start doing anything else? Right? I think you better do that. So this is y plus 1. And now, Gracie, I think we can subtract that 1 from both sides, right? Okay. So these two equations, they're what we call equivalent. They're not the same equation. They're two different equations. But if we graph them, wouldn't they be the same line? The same ordered pairs make them true. Okay? And so there you have it. Okay, you guys got a piece of paper you can work on? Okay, here's a couple, wait, here's a point. I'll just do a point. Negative 4, negative 5, and here's a slope, 1/2. So I want you to write this equation in point-slope form, and then I want you to convert it to slope-intercept form. I want you to solve for y. Go ahead, whatever it takes. Okay. Oh. Destiny, you want to help me? Or even if not, will ya? What do you want to write first?
Y minus negative.
Oh, she had me with y subtract. Good enough? Nakai, what goes next? Say it louder. Oh, yeah. Let's see here. Daniel, what goes right here? Is that what you said?
1/2.
Oh, 1/2. Okay. 1/2. Good. And then Kylie, what goes in the parentheses?
X minus negative 4.
Okay, do we have the -4 and the -5 in the right place? Do you all have the double negative going right? Okay. So, Ryan, what do you see right now we better take care of? Yeah. Yep. We want to take care of that business before you try to get rid of the parentheses, before you solve for y. We want to kind of simplify things as much as we can, right? So now it's a little easier to say 1/2 times x and 1/2 of 4. Does anybody struggle with 1/2 of 4? You probably wouldn't if you said it that way. If you say 1/2 times 4, you might think, oh, I don't know. But if you think 1/2 of 4, yeah, we got that. Okay. Last step, Easton. What do you think?
Y. So you got minus the 5.
Okay. Subtract 5 from both sides. I'll just show my work like that. So y equals 1/2 x subtract 5. No, it doesn't. 3.
Negative 3.
There we go. I'm getting it. Okay. That is actually what I've written down here, and that's where I got that point from. I put -4 in here and said half of -4 is -2, subtract 3 is -5, and then I just used that slope. So I knew that when we work this out, that would be the equation we come up with. Okay? Now, I want you all to turn to page 173. There's an example 2 right there at the top of the page. There's a graph, right? Got a couple of points on it. Now, I'll write down the 2 points. 1, 2, and then 3, -2. Okay? I can do the slope formula. So 2 subtract -2 and 1 subtract 3. That's positive 4 over -2, which is -2. Or I can just look at the graph and start at the left-hand point and say, you know, it looks to me like we have to go down 4 and then to the right 2 to get to that next point. I mean, you can literally count the slope there, can't you? So you don't have to do the formula all the time. You know, if it's on a graph and you can see the slope, that's fine. So we know the slope's -2. Okay? So here's the deal. Shannon, everybody from Shannon over, I want you guys to use this point and the slope, do point slope form, come up with an equation. Everybody on Destiny's side over here, I want you to use this point and the slope and come up with the equation. Right point slope form and then solve for y. So you have slope intercept form, right? Okay. Luke, what'd you get?
Y equals -2x plus 4.
Okay. Dacelin, what'd you get?
Y equals -2x plus 4.
So even though you both used different points on the line, it worked, didn't it? Could we choose another point on that line and still come up with that same equation? Yeah. So here I've done it. I've done both of yours, depending on which point you used. Okay. But let's just look on that line for a minute. Can you guys pick out a different point that is certainly on that line?
2, 0.
Okay, I heard 2, 0. There's one. Can you see a different point that's on the line? 4, -4? If I used either of those 2 points and the same slope, should I come up with that same equation? Yeah, and I'll just use this one because it looks harder. So y subtract -4 equals -2 times x subtract 4. So this is plus. And y plus 4 equals negative 2x plus 8, doesn't it? Plus 8. Subtract 4 from both sides, and y equals negative 2x plus 4 still, doesn't it? Okay, it's going to work no matter which point on the line we use, which is kind of cool. Okay, so now, the next thing that's going to happen with you guys is they're just going to give you the 2 points. They're going to give you 2 points like this. Okay? And they're going to ask you to find the equation of the line in slope-intercept form. So there's a lot of work to get there. What's the first job that we really have here? Yeah, we got to find the slope. So you've got to be able to do this right. Tell me what to write. 4 minus 10? Negative 6. Okay, so you have about, I don't know, 8 ways to screw that up, wouldn't you say? I mean, if you don't do y over y, if you, for some reason, went 4 minus 10, and on the bottom you went 3 subtract 1, that wouldn't work, would it? You have to go the same direction. Little subtraction problems that are easy to mess up. We got a negative over a negative, which is positive, and 6 divided by 2. None of that's difficult, but there's a lot of little things you can mess up, right? So be careful. Now, which of these 2 points do I have to use? Okay, did we all get that? One of you said it doesn't matter. Everyone else stared at me. Which of the 2 points do I have to use?
Doesn't matter.
Ah, yeah. Okay, it doesn't matter. Now, sometimes 1 point can be easier, though. Like, would you guys take points that had positives in them or negative coordinates? Which do you think would be easier? I think negatives. Because when you put the negative in, you get a double negative, which it becomes what? Positive. Yeah, it becomes positive. So, so I don't know about that one. That you could argue both ways, I think. But I'll tell you one thing. If one of these 2 points had a 0 in it, I'm taking that one. Because if I can put a 0 in my point slope form for either x sub 1 or y sub 1, that's going to make life easy, isn't it? Okay. So let's just use this one here. Y subtract, everybody, what? 4. Keep going.
Equals 3 x minus 1.
Okay. So there's the equation of the line. Now we can solve for y.
4 equals 3x plus 3 minus 3. Oh! Guys.
There it is.
Yes, sir.
So yesterday I showed you this point slope form. We talked about it a little bit, and I tried to do it right at the end of class. It made you cry a little, and then you went home and thought about it, and by the time you came back today and we did it again, it doesn't seem that bad, does it? Okay. You just have to have a minute to absorb it. Okay. So turn the page over now and let's look at a more realistic type of problem. I know, linear model. Okay, a linear model now. The student council is ordering customized foam hands to promote school spirit. Nothing promotes school spirit like a customized foam hand. The table shows the cost of ordering different numbers of hands. Can the situation be modeled by a linear equation? Explain that. If possible, write a linear model that represents the cost. Okay, so here's the number of hands, and this is the cost. And they just have a table for us. 4, 6, 8, 10, 12, 34, 46, 58, 70, 82. So the first question was, can this be modeled by a linear type of expression? Do we see a constant rate of change?
Yeah.
We do? So the change in x, what's happening every time? Plus 2. And the change in y? Adding 12 each time?
Yeah.
Okay. is that enough for us just to say what the slope of this line is, or the rate of change? The rate of change, what's the change in y? And the change in x? 2. Does that reduce down? 6 over 1. What does that 6 over 1 mean in the context of this problem?
For every 6 hands, that's 6 over 1. Oh, for every $6 1 hand?
Yeah. Yeah. Well, wait a minute. Is it for, do you get 6 foam hands for $1, or is it $6 for 1 hand?
Yeah, what you said the last one.
What I said on the last one.
Yeah.
So which is dollars here? The top or the bottom?
Top.
This is dollars.
Yeah.
This is dollars, and this is hands, right? So it's $6 for.
1 phone hand.
Okay, that's what it means that's what the rate of change means in the context of this situation. You guys get that?
Yep.
Okay. Now, we got the slope. We got a bunch of points. Can we find an equation?
Yeah.
Let's do it. Which point you want to use?
434.
That one work?
Yeah.
Probably not a bad choice since it's the smallest point, right? So y subtract the y value equals the slope, which is just 6, times x subtract the x value. I don't like this equation because it's not x and y's, but we'll fix that later. Y subtract 34 equals 6 times x subtract 24, and then add 34 to each side, and y equals 6 times x plus 12? No, plus 10, huh? Plus 10. Okay, so x, it's not x. What are we talking about here?
Hands.
Money. Yeah, money. Okay. So x is the cost, or wait a minute, is it money or is it the number of hands?
Wait.
Isn't it the number of hands?
Yeah.
Someone said money and I believed him.
What?
Ah! Okay, that's number of hands. This is the cost. And I will just say this, guys. If time is involved, it's always x. If money is involved, 99% of the time it's y. Not all the time. Okay? So this does seem weird though. Are they charging us $10 for 0 hands?
Yeah, what the heck?
That seems a little odd, doesn't it? It's like there's an initial charge of $10 and then it's $6 for every hand that we buy. What the heck is that initial charge of $10?
Good question.
It could be tax, but I don't think they'll charge us tax until we actually buy a hand. But what other costs might be involved in getting these hands?
Shipping?
Getting in.
Shipping. $10 shipping plus $6 for each one that you buy. Does that make sense?
Yeah.
There's an initial amount, there's an initial cost for our shipping, which doesn't change regardless of how many you buy, okay? And then $6 for each one that we get.
That makes sense.
Holy mackerel, something made sense! What do you say, Mason? You ready to do this? All right, let's do it.
That'd be $10 for wasting their time if you only got 0.
Well, yeah, and would a company ever do something like charge you the same amount of shipping regardless of how many you buy in an effort to encourage you to buy more of them?
Yeah.
Because you're like, well, I'm not going to pay $10 shipping just to get 2 or 1. If I got to pay $10 shipping, I might as well get, I don't know, 100 of them. Do people fall for that?
Yeah.
Oh, yeah. Heck yeah. Okay. Chapter 4.2. 1, 2 through 34, the even. 38, 40 through 44. I think you can get it done in class. No homework this weekend. It will be so nice. Let's get to work.